Hello, this is Jeff again at Rhodes College, and I'm going to talk about a new randomization technique called permutation testing that we can implement in Fathom. Permutation testing is useful in a variety of contexts, but we're particularly interested in it because it can allow us to test the null hypothesis h0 rho equals 0 against an alternative hypothesis that rho is not equal to 0 or that rho is greater than 0. Here's how we go about executing a permutation test in Fathom. So I have here the breakfast cereal data that we've been working on in class recently, and I have pre-computed the quantities sugars per cup and calories per cup. Remember that we've already learned how to compute the sample correlation coefficient between these two variables, but the question remains, is this sample correlation coefficient of 0.53, does it provide sufficient evidence that the true correlation, which we can never know, that the true correlation between sugars per cup and calories per cup is something other than 0? Permutation testing will help us answer this question. And the way we execute a permutation test in Fathom is through an operation called scrambling. So here's how we do that. I'm going to shrink this table right here a little bit to get it out of the way, and I'm going to right-click on the breakfast cereal data box, the raw data box, and ask to scramble the attribute values. So I click on this, and Fathom creates a scramble box for me. Let's take a look at the output of the scramble box. Let's create a table associated to it. And you'll see that at the moment it looks exactly like the original set of data because nothing's been scrambled yet. To begin scrambling, what I'm going to do is double left click on this box and choose the attribute that I'd like to scramble. I'm going to choose to scramble the attribute calories per cup. And notice what happens when I press this button repeatedly. The values in the calories per cup column right here are randomly scrambled. Okay? So in principle, there's no longer any meaningful connection between sugars per cup and calories per cup because whatever original connection was there, I've now shattered that by engaging in this scrambling. Let's see if that actually holds up when we measure the connection between scrambled calories per cup and sugars per cup with the sample correlation coefficient. How am I going to do that? Well, let's take a summary table here and drop in sugars per cup and calories per cup from the scrambled table. So now what I see is that the sample correlation coefficient when I randomly scramble the data, when I permute it, is 0.09. If I do so again, that sample correlation coefficient is now 0.02. Now it's slightly negative, now it's slightly positive again, now it's slightly negative again, and so on and so forth. Okay? In fact, often it seems that the average of the sample correlation coefficients we're generating in Fathom is equal to 0. So another thing that we should note is that we rarely see values as large as or larger than the original sample correlation coefficient between sugars per cup and calories per cup. That suggests that it really is truly the case that there is a correlation, a positive correlation between sugars per cup and calories per cup. So I'm going to go on ahead and pause the video here. In part 2 of this video, we will repeatedly scramble and collect measures from those scrambles. The measure is obviously going to be correlation coefficient, and we will create a randomization distribution, plot our original measure from our data against that distribution, and compute an empirical p-value.